This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be solving one of the issues with our improved jumping system, which is that we can press the jump button and perpetually jump into the air. Now we are going to be using our optimized jump and better jump scripts here, so if you haven't updated those already, do go back to the optimization video that comes before this one, and make sure that your physics calculations are being done in the fixed update methods. So with that, what we're going to do is we're going to jump into our jump script because this is really where we're going to be deciding whether or not pressing the jump button does anything. When we do detect that the jump button has been pressed down, we want to look and say, is our character grounded on the floor or are they up in the air? Because if they're in the air, they shouldn't be able to jump. And so it's right in here that we're really going to be taking a look and kind of checking some sort of Boolean to say, are we in fact on the ground? And there's a few ways we can approach this. So what I'm actually going to do is jump back into the inspector here, or into Unity, and we are going to create 3 new scripts based on this jump script. So I'm going to create a C# script, and I'm going to call this one jump collision. I'm going to create another called jump Raycast, and the third is going to be called jump box. And that may give you some idea of what I'm going to be doing with each of these. But now we're going to open up each of these in monodevelop. And I'll just grab them from here. Jump box, jump collision, jump raycast. I'm actually going to move box will be the last one we do. And the first thing I'm going to do is I'm actually going to copy the content that we have in here into each of these. Paste that in there, paste that in there, and we'll paste that in here. Now one thing to note, the original jump video I did was in Unity 5. This is now Unity 2017. None of this code should need to be changed because of that. The one important thing, if you are still using Unity 5, is that 2017 automatically adds this using system.collections.generic. If you don't have that in there, do add it, particularly to the jump collision, because we are going to be using it. So the first thing, and this often comes to mind for a lot of people, is, well, my player has a collider, my ground has a collider, so shouldn't I just be able to check if there's a collision between them and use that to determine if I should jump? And you can do that. However, it tends to get a little bit more involved than you initially think, because while you can check when there is a collision, you can do things, it's not all that easy to say, you know, hey, is there a collision going on right now? We couldn't just say right here, you know, jump button being pressed down and collision something. What we do need to do is we need to keep track of whether or not there is a collision in some way. And there is actually a fairly convenient way to do this, particularly in 2D. And what we're going to do to do that is we're going to add in a list here below our jump request. And this is going to be list collider 2D, and I'm going to call it ground touched. And this is just going to be a list that keeps track of how many pieces of ground, if any, that we are currently touching at a given time. If there is some ground that we're touching, then we know that we can jump. And I'm going to just automatically set that to a new list, collider 2D. Again, if you're not getting the list autocompletes here, make sure that you're adding system.collections.generic up here. In addition, what we're going to do now is we're going to check in our update, in addition to the jump button, we will say ground touched dot count does not equal 0. So what this will tell us is if there is some ground that we're touching, if there's at least one piece of ground we're touching, then we can jump and then we can do this. Otherwise, there must be no ground we're touching and we're just going to ignore this and fall out of the method. Now the other thing we need to do here though now is keep track of the ground being touched, and we're going to do that using the collision API. So we're going to say here void on collision 2D, and that takes in a collision 2D parameter, which we'll just call C. And in here what we're going to do is we're going to check a couple things. First, we're going to check that there is in fact a collision with the ground, but also that we're not just like, say we hit a wall. We could hit a wall and that does register as a collision, but it's not something that we can necessarily jump off of. What we really only want are we want to be on top of flat things that we can jump off of. So what we're going to do is we're going to create an array of what are called contact points. And these will carry the information of what the facing is of the object we're colliding with. So we're going to say contact point 2D array, and we're going to call it points, equals a new contact point 2D array. And we're just going to put in 2 values for this. That should be enough to get the information we need. Next, we're going to say c.getContacts, and then we're going to put in points as a parameter. And what this does is this kind of fills in this points array with whatever the current collision is. And then we're going to say for int I equals 0, I is less than points dot length, I plus plus. And so we're going to go through each point and we're going to check if any of these collision points are in fact pointing straight up. And so we'll say if points I dot normal, which is the direction, as you see here, the surface normal at the contact point, meaning what direction that surface is facing, equals vector 2 dot up. Then, and we also want to check, what we're going to do here is we're going to add, so we'll say ground touched dot add, and we're going to add the collider 2D that we're currently colliding with. So that's going to be c.collider. Now it's a little misleading because there's also an other collider variable, but that's the other collider is actually yourself, or the object itself, not the one that's colliding with it. So be sure to use collider here. And then we're simply going to return at that point, because we know at that point that we've successfully touched the ground. We don't need to check the other contact points. Now the one issue with this is that we could end up, if we collide multiple times with the same piece of ground, we could end up piling up a lot of kind of copies of that, and that might give us some weird results. So we do want to check before we add this collider that it isn't already in the list. So we're simply going to say up here, and ground touched dot contains c dot collider, and we want to make sure that that is not true. So if it's not already included in the list, then we'll add it to the list. Lastly, we need to make sure that when we do say jump or we fall off a piece of ground, that we, as we're exiting that, and excuse me, I miswrote here. You may have caught this already. It should be on collision enter 2D, not just on collision 2D. So when we leave a collision with the ground, we want to say void on collision exit 2D. Again, we'll have the collision 2D parameter. And in here, a little bit simpler, all we're going to do here is we're going to say if ground touched contains c.collider, then we can simply remove it. So we'll say ground touch.remove c.collider. And we're missing a parenthesis there, but there we go. So now once again, all this is doing is saying when we touch the ground, we'll add it to a list, and when we leave the ground, we'll remove it. So if the list is ever empty, we know we're not touching any ground and we can't jump. So we'll see here, if I hit play now, whoops, can't quite do that yet because we do need to make sure that we actually add this. So we're going to say add component, and I'm actually going to add all 3 of these. So jump collision, we'll add jump box, or jump raycast, and jump box. I'm going to close these a bit here because we don't need them. I'm going to turn off the basic jump script as well as the raycast and box for now. So only this and the better jump are functioning. Save that, and we'll hit play. And now what we'll see, if I increase this to actually have a jump velocity, make sure you do set that up to a value. is now if I hit jump, we jump normally, but if I try to jump in the air, it doesn't work. It's only when I'm touching the ground that I actually jump. So that is one solution for jumping, and that's using a collision to do so. It's a little bit involved because, as I say, we have to check these points, we have to go through the points, we have to double check if it's a piece of ground that's facing upward, and it's also a little bit limiting right now because this has to be facing exactly up. There are ways to give you a little bit more flexibility there, but from there we're going to be adding more and more code to check this, so I think there are simpler ways we can do this. The next one, in fact, is called a jump raycast. And how this works for us is that instead of just checking, every collision that we have in the world, we're going to once again check if we're grounded. And how we'll do that is we will do a raycast below us, which is basically kind of drawing an invisible line below our player that's going to see if it intersects with any other objects. So here what we'll do is we're going to add, instead of having this list here of ground touched, we're simply going to have a Boolean called grounded. And what we're going to check here is if the jump button is being pressed and if we are grounded, so and grounded, then we will jump. Now, one nice thing we can do here is we can say if we're successfully jumping, then we can successfully say that we are probably grounded and we no longer want to be grounded because we're going to be jumping out into the air. So we can quickly say here grounded equals false. And even if for some reason, maybe we jumped and hit a ceiling immediately, this will actually fix itself within the next physics update, so it will be helpful for making sure that we're not jumping immediately after we jump, but it will also resolve itself if need be. So this is all what happens if we jump. If we're not jumping, however, what we want to do is we want to check if we are grounded. So in order to make this work, we're going to have to add a few variables. The first one is going to be a public variable so that we can adjust it. It's going to be a public float called grounded skin. And what that is going to be is basically the thickness below ourselves of how far we want to actually check if there is a piece of ground that would qualify as us standing on it. I'm going to do something pretty small. I'm simply going to say 0.05F for now. That's pretty small. You could even go thinner if you wanted to, or thicker. It's really going to depend on the needs of your game. The other thing I'm going to add is a public layer mask. And this is going to be so that we don't accidentally detect our player being, like touching, the raycast touching the player. So we're just going to add a layer mask called mask, which is we're going to set in the inspector in a few minutes. So with those two there, the other thing we need is a vector2 called the player size. And this is going to just be so that how raycasting works is it uses world space. So we need to always be aware of the size of the player to offset that from the position of the player so that we're checking properly. And so I'm going to simply create a void awake method. And in here, we're going to say player size equals get component box collider 2D dot size. If you're using a different type of collider, then you may need to get, like if you're using a capsule collider, you may need to store this as like a separate height and width. But for the case of our box collider right now, we can simply get the size. With all that, we can now actually set up our raycast. So our raycast is going to need a few pieces of information. It's going to need a source, like the point where it starts. It's going to need a direction to go. We know that's going to be directly down. It's going to need a distance. That's going to be whatever our skin here is. And we're going to have the layer mask to make sure that we don't accidentally detect colliding with the player itself. So with those, the one that we still need to figure out is where this starts. So we're going to say vector2 ray start equals, and we're going to do the transform dot position, and we're going to actually cast that to a vector2 to avoid any ambiguity in our code. And then we're going to say plus vector2 dot down times the player size dot y, so the height of the player, times 0.5, so times half of the player, because this position is in the center of the player, and so we're going down, halfway down the height of the player, so basically to the exact bottom of the player, and that's where we're going to start our ray. From there, we can actually set our grounded equal to the result of the raycast, because if you do physics2d.raycast, you will see, well, it actually returns a raycast hit 2D, but if it doesn't intersect with anything, that will basically be the equivalent of saying false. And it returns null, I believe, which is basically tells Unity to set grounded as false. So we're going to do raycast, and the first thing is the origin, so that's the ray start. Then we have the direction, which we want to be vector2.down. Next we can add a distance, and that's going to be again our grounded skin. And finally, this mask. And this is, you'll notice it's an integer, but Unity will automatically convert that from a layer mask to an integer for us, so we can simply say mask. It's just, you can actually put in the integer of the physics layers you want to use or ignore. It's a little bit easier, though, I find, just to make it a public variable up here and set it in the inspector. So with all that, we've now got all the information here we need. We just need to jump back to the editor, and we're going to go, we'll see here if this updates properly. We're going to turn off our collision jump, and instead we're going to use our raycast jump now. And sure enough, we have all our information here. We're going to set the jump velocity back to around 5. Grounded skin, we can change it here if we feel we need to. And then this mask here is again where we want to double check that we're not intersecting with the player. So what I'm going to do here is I'm going to say it should only intersect with the default, which right now is what our ground is. You'll see up here the layer is default for our ground. However, our player is also default right now, so what I want to do is I want to add a layer for the player. I'm going to go down here, user layer 8 is the first one we can use, and so we're going to say player. Save that, jump back over to the player, and always remember when you add a layer, you still have to actually actively set that back. So now we're going to set that layer to player, and now we know that this raycast is only going to intersect with default layer objects. It's never going to intersect with our player. So we'll save that, hit play, and now what we should see is once again that we can hit space and we jump as normal. However, if I hit it when we're in the air, it doesn't work because we're not grounded. You can actually see this in action too. If you go up to this drop-down menu here and you go to debug instead of normal view, you'll notice a lot of extra stuff pops up, but navigate down to your raycast and you'll see down here it's grayed out because it's not a public variable, but we have this grounded. And you'll see that as we jump and we get into the air, it's no longer grounded. However, this isn't a perfect solution, and the reason for that is I can show you is if I duplicate the ground here and I move this piece of ground over like this and create a gap, and then I take these both and bring it like this and kind of create this hole underneath the player, and I hit play. If we look at the player, you notice now it's not showing it's grounded. And then sure enough, if I try to jump, I can't do it. Unless I actually take these and move them over again. Now I can jump again, because the problem is I'm only raycasting from right in the center of the player, meaning we're really only doing a check at one point across the entire width of the player. And if there's a hole in that one particular spot, then you're going to get this sort of a false negative of saying, oh, there's nothing here, even though visually to the player, there's definitely ground that they're standing on. Now, there's a couple of solutions to this. One thing we can do is we could actually set it up where we have a number of raycasts going like here, 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 like just create a whole row of raycasts, and it's perfectly doable. It gets a lot more involved. However, there's still going to be, potentially you could have a situation, unless you're doing, an absolute crazy number of raycasts that might even slow your game down, there's always this possibility of having points that get missed. And so the other solution, which is our last option here, is the jump box. And what we're going to do with that is we're going to use a box to check for overlaps through the entire width of the player, which will kind of solve that issue of the raycast. So how we'll do that is we're going to go to our jump box script. And actually what I'm going to do is I'm actually going to copy the jump raycast content now, because this is a lot closer to what we need. So I'm going to simply copy that from jump raycast and paste all that here. into jump box. Now there are a couple of changes that we're going to need to make. The first one is I'm going to create another vector2 up here, and I'm going to call this box size. And this is going to be, we're going to have this consistent box size. Every time we check this, it's always going to be the same kind of size box that we're going to check for an overlap. So we can calculate that here. And what I want that to be is the width of the player for the width, and then for the height, it's going to be this grounded skin value. So we can simply set that in awake, and we're going to say box size equals get component, or not, sorry, box size equals new vector2. And in here, we're going to say player size.x for the width of the player, and then grounded skin for the height. The other thing we need to do is we obviously need to change this. We no longer need array start here, so we can delete that for now. And we're not going to raycast. Instead, what we're going to do is we're going to use another physics 2D method called overlap box. And you notice what it returns is a collider 2D. Basically, if there are any colliders intersecting with this, then it will return it. Otherwise, it will just return null. And so kind of similar to how in our list in the collisions, we were checking, is there anything in the list? Similarly here, we're going to just check, is this null or is there something there? So we'll say overlap box. We'll put in the information in a minute, and we'll simply check, does it not equal null? Now this looks a little bit weird because we have an equal sign here and then a not equal there. So I'm going to simply throw this into parentheses. Unity would probably handle it just fine, but it's a little bit clearer for us. Now what we do need here though are our parameters. And so if I open this up again, we see the kind of tooltip here. We see we need a point, and that's going to be the center of the box. We need a size, which is the overall size of the box. That's going to be our box size up here. Angle is if you want that box to be rotated in any way. We're just going to use 0 for that. And then we're going to, again, use our layer mask. And that's why I kind of copied this, because we already have our layer mask and that put into here. So the one we do need to calculate, though, is our starting point. So I'm going to create a vector2, call this center point. Or actually, I'll call this box center, since we're doing box size. Box center equals, and this is going to be, once again, we're going to use transform.position, because we always need to base it on, this is again in world space, and we need to base it on where our player's current position is. And again, I'm going to cast that to a vector2. And then we'll add to this, again, vector2.down. And we're going to multiply this. This time, though, we need to multiply it not just by the height of the player, but also by the height of the box, because, again, this is going to be the center of the box. So we don't want the box to be overlapping the player at all. We just want it to be like sitting exactly resting on the bottom of the player. So we're going to say player size dot y plus box size dot y. And then we're going to multiply all that by half, because again, it's going to be half the height of the box to get to the center of the box, and half the height of the player to get to the bottom of the player. So now in here, we need to actually put in our parameters, which are going to be the box center for the starting point of the box, the center point of the box size for the overall size of this overlap box. Angle is going to be 0f, and the mask, we're going to use, again, our mask variable up here. So we save all that, jump back over to Unity. Again, we'll go to our player here. I'm going to switch over to our jump box. I am also going to switch back to the normal view. Again, up here, this drop down, you can switch between debug and normal. And we're going to make sure that our jump velocity has a value. And we're going to make sure that our mask is only set to the default and not going to interact with the player. Save that again, and now we'll see here, even though we have this gap below our player, we should be able to jump as normal. Again, I can show you the debug view. You'll see the grounded value here. It is checked off at the moment. When I jump, it no longer gets checked off, but it's checking this entire width here for us, all the way from this point over to here so that we don't have any sort of mishaps of, you know, if just so happens that there's a gap where our raycast is, we suddenly don't think we're grounded. So collisions, raycasting, and this overlap box are three methods that you can use in order to check for grounding and no longer have your player, you know, flying into the air infinitely. So hopefully this helps you guys out with your game development, and thanks so much for your comments on the past videos. They really help to inform these past couple that I've done, and thanks for watching, and I'll see you next time.